Okay, everybody, so I'm going to talk about some fractions today. So we're done with the real numbers and the signs. Today we're going to talk about another type of real numbers, which is fractions. First of all, so let's define them. Let's define fractions. Later we're going to see how to simplify them and also how to convert between mixed numbers and improper fractions. Let's start with the definition here. Can you guys hear me okay? Everybody?
Yeah.
Yes. Okay.
Yes, Professor.
All right. Very good. So let me just bring this screen over here. All right. So a fraction basically is, if you want to define the term itself, a fraction means a portion. So a fraction of something is a portion of a whole. Is a portion of something. So sometimes you say, have a fraction, I pay a fraction of the price, or I do this or do that, meaning just a piece of, a little bit of some whole piece. Let's say, take the example of a pie or a pizza like this. So this is a whole pie, one piece. Let's say you want to get maybe just 1/4 out of this, 1 out of 4, which is basically 1/4. So we're going to get this fraction exactly out of this pie. So how do you do that? What is the first thing you do? What's the first thing you want to do in order to get exactly 1 out of 4 or 1/4? Another thing we say is 1/4.
Do you need separate?
Say it again. I'm sorry, get a microphone a little bit.
You need separate 4 parts.
4 parts. That's right. We have to divide this into
Yes.
4 parts, and then we take
One.
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 Or 4 parts.
One is all.
Right. So 1/4 shaded here is 1/4. It is shaded in this case, or you can cut it, whatever it might be. So what's left? What is the fraction of the non-shaded part?
3 out of 4.
That's right, 3 out of 4. So 3, 1, 2, 3 out of the total of the pieces, which is 4. So this is a little example of what fractions are, basically a piece of something. Let's say I have this whole piece, whatever it might be. It's one piece, one whole, and I wanted to get exactly this fraction out of it. So this is 3 out of 5, or 3/5. So 3.
Without that, that's difficult.
Okay, so 3/5. How do I get 3/5 out of this whole piece? First we divide it into how many equal pieces?
5.
Do 5. That's right. Always divide by
5.
this number here on the bottom. And want to, let's try to get 5 equal parts here. Okay, something like this. Have to be equal, and then you take 3 out of those. For example, this. Any 2 basically, because they're all equal, so it doesn't matter which pieces you take. unless you cut in bread or something, of course you don't want to jump to the middle. You want to go piece by piece, but that's the idea. So 3 out of 5, 3/5 is shaded, and the other part that's not shaded is what's left, 2 pieces.
2/5.
That's right, 2/5. So that's the idea of fraction. So a fraction has 2 sides, as you see. You have top and bottom, which have specific names. What do we call the top number of a fraction?
The numerator.
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 Very good. Numerator. And the bottom is?
Denominator.
The denominator.
Exactly. Denominator. And depending on which one is larger, the fraction could be either proper or improper based on these numbers. So we see which one is higher. So we have types of fractions. So A over B So if A is larger than B, if the number at the top is higher than the bottom, what type of fraction would that be?
Improper.
That's a proper fraction?
I just said that to improper fraction.
Okay, that's right, improper.
Oh, okay.
Improper.
Say that again?
Improper fraction.
No.
Okay, so when the number here is higher, A larger or greater than B, this is called improper. For example, 7 out of 3.
Okay.
And maybe 8 out of 5, and so on. 11 out of 4. So all these are improper fractions simply because the number at the top is higher. And we're going to see that we can change these into another type of number in a moment. What if A is less than B?
Proper.
That's right, would be the opposite of improper, which is proper.
That would be a proper fraction?
That's right, would be proper. Examples, 1/3, 5 out of 9, and so on. 6 out of 11. So all these are proper fractions because they make sense. When you say 1 out of 3, just like we did earlier, we divide into 3, you take 1. For this one, you divide by 9, divide the piece, whatever it might be, into 9 equal pieces, and you take 5 of them. This one does not make sense. You divide by 3 and you take 7 out of those. You divide by 3 and you take 7 pieces, but we only have 3 pieces. Doesn't make sense. So we're gonna need, this is basically more than a whole. This is, we have a whole and more. For example, here we may have, if it's a pizza, we may need more than one pizza. So we're gonna need a whole and a fraction, some fraction here, for example. So this is what we call a mixed number. Okay, so this one requires a mixed number. You need a whole and some change. These are proper. If you have 1, that's enough. You can take 3. You can divide into 3 and take 1 out of it. Here you can divide by 9, and you can take 4 out of those 9s. These make sense. They're proper. These are a little improper. They require more than just one whole piece. Depending on how many pieces you want to take, could be you may need 1, 2, or 3 more wholes. For example, pizzas, to get exactly what you want for you, like this. Okay, so let's see how to turn these into some mixed numbers. So we're going to say improper fractions. We're going to turn them to mixed numbers. Okay, for example, we have 7 out of 3. So this, again, you can divide by 3, but 7 more than that doesn't make sense. So what we do is we're going to see how many wholes we're going to need in addition to some fraction. So we say 3 into 7. How many times is 3 going?
2.
2.
3 into 7, you say 2.
2.
Mm-hmm. You make
2
a lot.
1/3.
That's right. You make a lot of fraction. You bring over the same denominator. If this goes into this twice, which is 6, how much is left from 7?
1.
1.
That's right. So now we have, let's say you want to make this, you're going to need 2 holes, for example, 2 pizzas and 1/3 of a pizza. So technically you're going to need 3 pizzas, and you're going to take 2 and a third of the other one. So this is 2, the whole part. This is the fractional part. That's why it's called a mixed number, a whole number, and a fraction. So we say 2/3. I mean 2 and 1/3. So 2 is the whole part and 1/3.
From the other part.
That's right. So let's say if this was pizza, you're going to take 2 whole pizzas, and then you cut a piece, 1/3 of the other pizza, in order to get this fraction. Okay, so that's how you could turn improper fractions into mixed numbers. You may also, let's say the other one here, 8/5. Let's also turn it into, let's turn it into a mixed number. So what is the whole part? 5 into 8 is?
1.
That's right, 5 goes into 8 once. Let a line here. Same
so
denominator.
3.
And 3. 5 goes into 8 once. The remainder, or what's left on here, is what goes here. So 1 and 3/5. Okay, it's pretty simple to divide or to convert improper into whole numbers. Let's do this last one. So these are separate examples. This is not a minus sign. 11/4. As a mixed number, that would be?
2.
That's right, 4 into 8, into 11, that's 8.
That's 4 quarters, 2, right? 3, 4.
That's right. What's left?
3.
3. So 2 and 3/4. 2 and 3/4 is the mixed number. So again, each mixed number has a whole part. And of course, in addition to the whole part, we have the fraction part. So that's why it's called a mixed number. The other type, the proper ones, cannot be turned into a fraction, cannot be turned into a mixed number.
No.
For the same reason, for this very reason, because this doesn't go into this. The denominator doesn't go into the numerator. So 3 does not go into 1. 9 does not go into 5. In other words, you could say 3 goes into 1 0 times. So that's your mixed number. If you want to write as a mixed number, 0 and 1/3. Pretty much nothing here, because this does not go into this at all. But this does go into this 2 times. So we have a whole part and 1/3. So you can consider this an invisible whole number here, 0. So 0 and 1/3. But we don't need to do that. We don't need to turn these into mixed numbers because they're proper fractions. And the whole part is basically 0. All right, so types of fractions. Now let's look at something called, or we can do the other way actually, the other way around. Let's see how to go back from here to here. It is possible to go backwards, so I'm going to say mixed numbers. So mixed numbers to fractions. To fractions or improper fractions specifically. Let's take this very example. So we want to go back from here to here. Let's see how to get 7/3 from this mixed number, 2 and 1/3. Okay, As you notice, the denominator always stays the same, whether you go in from proper to fractions or the other way. Just need to figure out how to get this number here, which is 7. So 3 comes from here, same thing. We need to use the other numbers, or these numbers, to make this 7. So what do you do to get that 7?
Multiply and addition.
That's right. We're going to multiply. What do
2
you
times.
multiply?
3 times 2, 6, plus 1, 7.
That's right. Multiply this way and add the remainder. 2 times 3
Yes.
plus 1. And that gives you the 7. This 7 here. So from here to here, you divide basically 3 into 7. To go backwards, you multiply and add. Same way it works for the rest of them. Let's do this one as well. Let's take 2 3/4. We're going to turn that into this one. So again, always keep the same denominator. And this time, what do we multiply?
2 times 4.
2 times
3.
4.
Plus 3.
That's right. Always times this way. Plus 3. So this 8 plus 3, 11. So we can go back and forth easily between mixed numbers and improper fractions as needed. Most of the time, we're going to need to turn mixed numbers into this, add or subtract, do whatever we have to do, and then convert the answer, the final answer, back to this. We're going to talk about that in the future when we add, multiply, and do everything with fractions. Mixed numbers to fractions, so that's pretty simple. Next part is number 3. We're gonna talk about something called factoring. Factoring is very simple. You basically take a number and you just break it down into the numbers that multiply to that number. For example, 6 as a product of 2 numbers would be
3,
3 and 2.
2,
and 2. Very good. That's it. We just did what we call factoring. We factored 6 into these numbers. These cannot be broken down. So these are factors or prime factors of 6. 3 and 2 are factors of this. We can also do it this way, especially if the number is bigger. So we do go through 3, 2, and then we continue if we can break the numbers more. Do that until we can't divide anymore. So in this case, we stop here. But if you have a larger number here, let's say 18, start with any 2 numbers and multiply to 18.
2.
4,
9 and 2.
yeah.
Yeah, I said 2.
9, 2.
And some other number, or 3 and 6, whatever, any numbers you start with that multiply to 8. Then you need to repeat that as much as possible.
3 and 1.
That's right. So this 3 here, you can break it down into 3 and 3. Can you break down the 2?
No.
No.
1.
1.
1.
No, just 2 itself. So you keep it like that. So again,
Okay.
these are called prime numbers or prime factors. Prime factors of 18. So prime, it just means numbers that you can't break down, as opposed to composite. So we have prime numbers and we have composite numbers. For example, 9 is composite, but 3 and 3 are prime because we can't divide them. So prime numbers are numbers you can't break down. For example, 2, it just 2 cannot be broken down. 3 is a prime number. What about 4? Is it prime?
Numbers what?
Number 4 is it?
No. Number.
Why not?
I mean, earlier.
It could be broken down by 2.
Exactly. So prime, 4 is not a prime. If a number is not a prime, what is it? You said, I think I mentioned it earlier when I talked about 9. If a number is not prime, then it's
Factor.
factor.
Improper.
Factor.
Prime?
Prime factors?
Not prime.
This is prime. Well, you can't factor, but if a number is 4 or 6, something you can break down. We call it composite. Okay? Composite.
Composite. If we can break it down, right?
That's right. If you can break it down, it's called composite numbers. For example, 2, 3, 4 goes here. 6 is a prime or composite? 6, as we saw here. Is that a prime number?
No, 6.
Is that a composite?
Composite.
No.
Composite number.
Composite because you can break it down.
But prime number, no.
3, no. 3 is a prime number.
What about 7?
4, 6,
7 is a prime.
8,
Okay, and then we have 8.
8.
8 is composite.
That's right. 9,
Okay. Mhm.
9 like this goes here. You can break it down.
11
Then we have 10.
is prime.
Here, 11. That's right. 12 is prime or composite?
12 is
12.
composite.
Composite. What about 13?
Is prime.
That's right. 13 is prime, and so on. So that's basically what we do. We'll break it down until you get all the numbers like these. If you get one of these, then you need to break it down again until you end up with only prime factors. But that's what.
Teacher,
So one wouldn't be considered a prime or a composite number?
I'm sorry. Repeat that.
Would one isn't considered a prime or a composite number, or would it be considered a composite number?
So that's a good question. 1 is not a prime number, and I don't know if it's composite or not, but it's definitely not prime. For the simple fact that the definition of prime are numbers you can divide by 1 and themselves. By 1 and themselves. For example, 2, we can divide by 1, and you can divide it by 2. But 1 is itself, so it does not adhere to this definition. So 1 is not considered prime. I would assume it's composite, but again, you can't break it down. So I'm not sure if it's composite, but it's definitely not prime. Okay, so remember, the prime numbers start from 2.
okay, but teacher, composite number is 9.
You said 9?
Composite number or is prime?
Which one?
The number 9. Composite number is
It's composite.
9 or prime?
No,
It's a composite number.
composite, because you can
Composite.
turn that into 9 and 3 and 3.
Oh,
Okay.
okay.
So
Okay,
prime,
thank you.
these are here are the prime factors of 18. 9
Okay.
plus a composite. Okay.
Oh,
Prime
mhm.
start from 2.
Thank you, teacher.
What else? So
Oh, okay.
now let's see how to use this. The reason why we learn this factoring, maybe actually still maybe some more problems. When the reason we do this is because we need that to basically simplify fractions. Let's say, for example, 72. Obviously, that's a composite number. We can at least divide it by 2. So what is 72 in terms of 2 numbers that multiply to that? Any 2 numbers, doesn't have to be a specific pair.
7
7 and?
And 8? No. No, and 9.
7 and
8.
7 and 9.
7 and 9. Is it 7 and 9?
No. 9 and 8.
That's right. It would be 9 and 8.
Mm-hmm.
72.
Yeah.
Let's start with any numbers here, or you can start with 36 and 2. That's the same thing. So 9.
Yeah, 9 and 8.
7. What do you do after that?
9 and 8, teacher.
9 and 8.
Oh, I'm saying 8. So, and what do you do after this?
Then 3 times
3.
3 for 3.
And
4
4,
and 2.
2.
and then 2 times 2.
And then 2 and 2.
So make sure all your numbers are prime. say this one is not prime, we can divide it into 2 and 2. So gonna rewrite the whole thing again. So 3, 3, 2 and 2, and then 2. 1, 2, 3. So basically all these, if you multiply them back, so these are gonna call prime factors. No matter which numbers you start with, your end result should be like prime factors of 18. If you want to go back from these numbers back to 72, what do?
Multiply.
That's right, we do the opposite. Here we divided, we broke the numbers down. If you want to go back, if you do 3 times 3 times 2, 2 and 2, you will get back to 72. It's easier to do it this way as a tree instead of going vertically or horizontally. Tree makes more sense like this. Okay, now let's apply this to simplifying fractions. So number 4. Or also called reducing. So let's say you have this fraction here. So 15 out of 35, that's a proper fraction. We have the numerator here, the denominator. So we're going to see if we can make this a simpler fraction with smaller numbers. We're going to keep the ratio the same. It's the same division, but with smaller numbers. Let's say we want to shade. If you want to shade this,
3 going to 15.
Yeah.
5 times.
Both have 5. Like,
Yeah, they both have 5.
yeah.
so
5
5
times 3, 15. And 5 times 7 is 35.
Very good. So both of those have 5 in common. So let's say you want to shade this now, 15 out of 35. It's going to be a lot of work. You're going to divide into 35 and then count 15. But you see that after simplifying it, it will be much easier to shade. If we wanted to shade it, or you wanted to cut a piece out of some hole, so you want to make it simpler first. So to do so, you notice what goes into both, which is good. Or you can factor this, same way we did here. What are the primes of 15? Prime factors?
3
and
5.
5. That's right. We factored it. You can factor the other one as well, same way.
7.
7 times 5.
And 5. So that's how do you simplify. So once you factor, you cancel all the common ones. These are irrelevant. The ratios will still remain the same. We can get a smaller fraction. So 3 out of 7. So you know how easy it is to, if you want to ask someone to give you 3/7 or 3 out of 7 of a pizza, it's much easier than say, give me 15 out of 35 out of your pizza or something. So this will be just 7 pieces like this, 1, 2, 3, 4, 5, 6, 7. Then you shade 3 out of those. So it's much simpler to deal with the fractions that are simplified than the other ones. They also make more sense when they're simplified. They make a lot more sense than larger fractions. Always simplify your answers, your final answers with fractions. They need to be reduced to something that makes more sense like this. These again are pretty much same numbers. They are same numbers, one of them is simpler. If you divide it with 15 by 35, it's exactly the same as 3 over 7. The only difference is one of them is simplified. So we call these equivalent fractions. Like I said, the ratio is the same. It might not be the exact numbers, but they're equivalent fractions. And you can either do it this way by breaking down both numbers, or sometimes if you can spot the largest numbers that goes into both, you can do that as well. You can do it right away. Let's look at another one. Let's say you have maybe 14 over, let's say, 27 or 22. I mean, 24 or 28. So again, you can use factoring, break this down into all the prime factors. What's the largest number that can go into both?
2, 4,
2 goes into both, but it's not the largest. What else?
7? 7?
7.
7. You can divide both by 7 right away and write your answer. Or you can do it the easy way. So it's 14 is basically 7 times 2. And this is 7 times 4. Cancel the 7s, you get, actually, you can divide even more. So if you say 7 times 2, then over here you can say 7 times 4. 4 is 2 times 2. You can break them down on the side, both ends. Now we're going to cancel all the common ones. 1 against 1. So 1 against this one. And 1, 2 against another 2. You have nothing left here, but you can think of it as an invisible 1. Because when you times something by 1, it doesn't change. So 1 over what's left here?
2.
2. So it's 1/2. So 14 over 28 is just basically telling someone to give you a half of something. So it's easier to say this than to say that. That's most likely people wouldn't understand what that means unless they know what they do with fractions. But if you say, give me 1/2, everybody knows what 1/2 is. Just divide into 2 and take one piece. You may also have possible to have something like this.
Excuse me.
So 30 over 150. Obviously, that's a large fraction. Can we make it simpler or more understandable?
Yeah.
Okay.
Both,
What is
both
But
have
there,
10.
one?
yeah, 10. There's multiple numbers for 30 though.
That's
You
right.
have 5, you have 6, and you have 10.
Yeah, there's a lot of stuff. There's a lot of common.
And you have 3. I'm sorry, you have 3 too.
But what is one thing, one quick thing we can do right away and reduce the number first and then reduce it again? There's one quick trick you can do. Cross something out.
Oh, yeah, I know.
5.
30. Multiply
The first
by
is
5.
Okay.
5.
Or you can just cross out.
Exactly.
This always works, okay? Always, you can always cancel 1 0 against 1 0. If it's at the end of the number, the whole number. So you get 3 over 15. And you can repeat again, so you can say this is 3
1.
times 1, 3 times 5. Cancel. You get
1.
1.
5.
1 5.
1/5 is the same as 30 over 150. Again, this is something you can do easily. If you want to shade or cut something, you can easily do that. And you may have 45 like this, and possibly maybe 900, 9,000. So what can we do about this?
Cross the zeros.
That's right. So immediately cross out the zeros, but it's got to be 1 against 1.
Right.
So we end up with 45 over 90. What is the highest number that goes into both?
5 and oh shoot.
5 is
Damn it. 5 goes into 45 though, and 10 goes into 90.
9.
No, both have 9.
9.
Both have 9.
Oh, 9,
9 would be the highest number.
9. Sorry.
9.
very good. 9 is better.
I
What
just
if
remember.
Yes.
what if I tell you there is even a better number that goes into both?
What?
Both 9
5?
go.
Oh no.
Can you try if one of them goes into the other? The whole number goes into the other?
No. Yes, let me see.
For example, does this one go into this one?
I think, yeah, 2 times.
That's
2
even
times.
better.
Yeah, 2 times.
So 45 goes into 45 how many times?
2 times.
You can into 45, into itself once, and into here twice. You end up with 1/2. Okay, that's probably the fastest way, but you can still do 9, as you said, 9 times 5, and 9 times. So this one 9 times.
1.
10.
10.
10.
You can cancel the 9s. 5/10, which we can also reduce by
2.
1 and 5.
1/5. That's right. Because 5 goes
That's
into twice.
5.
1 out of 5.
So you can say 5 goes into 5 once, 5 into 10 twice.
Twice. 1/2.
1 over 2 is the final answer.
Yeah.
Okay, so feel free to take it one step at a time. You don't have to spot the highest number. But if you can see it, that's fine. You can do that. It may save you time. Otherwise, it's always okay to take it one step at a time. Or you can break down the whole thing if you want. What if I break it down completely into prime factors, just like this? Break down the 90 and then cancel out the common ones. But with experience, you'll see that you can spot the numbers right away and save yourself some time and some steps here. But feel free to do it either way. That's not a problem. Maybe even here, you will, in the future, you might get too, familiar with this. You can just say, oh, 450 is basically goes into this twice, so just 1/2. But again, take the easy way until you're comfortable with doing it the faster way. So that's the reason why we learn factoring, just so we can see the common numbers or the common factors, so we can cancel them. For example, here we saw 5, we saw 9, we saw 45 itself. Knowing the multiplication table helps with this a lot. Makes it very easy and quick to spot the common factors and cancel them out. And again, you don't have to write them out all here. You can just look at it, cancel the common factor, and then repeat again if you have to. If you don't get the highest one in the first try, that's fine. You may have to simplify again. Okay, so that's a lot of introduction to fractions. You guys have any questions on this so far? Everybody?
Oh, okay.
All good?
Thank you. Oh,
It's going to be very useful when we add, when we multiply, divide, add, and subtract fractions and mixed numbers. We're going to be relying on this. We may do this a lot quicker. We're going to skip some steps here, but for now, again, we're taking this one step at a time. All right, so if you guys don't have any questions, let me give you a few practice problems, give you some time to work on them. Okay, just like we saw before.